What if I told you that the world you know today, the cities, the farms, the entire foundation of human civilization, only exists because of a catastrophic disaster that killed off almost every giant animal on Earth? What if the comfortable modern life you're living right now was born from humanity's first massive environmental crisis? And what if everything you've been taught about the last ice age is completely wrong? If you enjoyed this mind-bending thought, hit that like button. Also, 99% of you that watch our videos are here to subscribe, so kindly hit the subscribe button. It helps our video reach more people who enjoy content like this. Welcome to the shocking truth about the last ice age, a story so incredible, so terrifying, and so relevant to our present moment that once you understand it, you'll never look at human history the same way again. Because what I'm about to tell you isn't just ancient history, it's a warning about our future, a mystery that scientists are still trying to solve, and a revelation that changes everything we thought we knew about how humans became the dominant species on Earth. Right now, as you're listening to this, you're living in what scientists call an interglacial period, a warm period between ice ages. But for most of the last 2.6 million years, Earth has been dramatically different from the world you know. Massive ice sheets miles thick covered much of North America, Europe, and Asia. Sea levels were 400 feet lower than today. The Sahara Desert was green and lush, and the planet was inhabited by creatures so massive, so incredible, that they make modern animals look tiny in comparison. Imagine stepping outside and seeing a woolly mammoth standing 14 feet tall, covered in shaggy fur, with tusks 16 feet long curving majestically upward. Picture giant ground sloths the size of elephants slowly moving through ancient forests. Envision saber-toothed cats with 11-inch fangs stalking herds of giant bison that weighed over 3,000 pounds. Think about dire wolves hunting in packs, short-faced bears standing 12 feet tall on their hind legs, and giant armadillos the size of Volkswagen Beetles. This wasn't fantasy. This wasn't science fiction. This was Earth just 12,000 years ago. And then, in what scientists call the blink of an eye in geological terms, these magnificent creatures vanished. Not just some of them, but almost all of them. Worldwide, about 65% of all large animal species weighing more than 100 pounds went extinct. And here's the truly shocking part that researchers are still debating today. We don't entirely know why. But the leading theories are absolutely terrifying because they point to either an environmental catastrophe so severe it wiped out creatures that had survived for millions of years, or to human hunting so efficient and devastating that our ancestors hunted these giants to extinction in just a few thousand years. And the most disturbing possibility? That both explanations are true. That humanity's arrival, combined with climate change, created a perfect storm of extinction that reshaped the entire planet. And that we're doing it again right now. But to understand this shocking story, we need to go back to the beginning. We need to understand what the last ice age really was, what caused it, and what it was like to live during that frozen era. The last ice age, technically called the Pleistocene epoch, began about 2.6 million years ago and ended approximately 11,700 years ago. But here's what most people don't understand. An ice age isn't just one long frozen period. Instead, ice ages consist of cycles, periods of extreme cold called glacials, interrupted by warmer periods called interglacials. During the glacials, massive ice sheets advanced across continents. These weren't just thick layers of ice. We're talking about ice sheets 2 miles thick in some places, so heavy that they actually depressed the Earth's crust beneath them. The Laurentide ice sheet covered most of Canada and extended down into what is now the northern United States. The Fennoscandinavian ice sheet buried Scandinavia. Glaciers covered the Alps, the Himalayas, and mountain ranges worldwide. Research published in 2024 examining ancient ice cores from the French Alps has revealed ice dating back over 12,000 years to the last ice age, providing an incredible window into this frozen world. Scientists can read these ice layers like tree rings, with each layer containing trapped air bubbles, dust, and chemicals that tell us about ancient atmospheres, temperatures, and even volcanic eruptions from thousands of years ago. But here's what will blow your mind. These glacial and interglacial cycles didn't happen gradually over millions of years. New research published in 2024 examining deep ocean sediments has revealed that climate changes during the Ice Age happened shockingly fast, sometimes within a human lifetime. Temperatures could swing by 16 degrees Celsius within just a few decades. Imagine that. Imagine living in a world where the climate could change so drastically in your own lifetime that forests turned to tundra or tundra bloomed into forests within a single generation. That's the world our ancestors inhabited, a world of dramatic, rapid, terrifying climate swings. Dr. Sidney Hemming from Columbia University's Lamont Doherty Earth Observatory, who led studies on Ice Age climate published in 2024, explains, "What we're finding is that Ice Age intensification was influenced primarily by changes around Antarctica. The climate system was responding to forces we're still trying to fully understand. And these responses happened far more rapidly than anyone previously thought possible." So what caused these ice ages? For decades, scientists have relied on the Milankovic cycles, variations in Earth's orbit and axial tilt that affect how much sunlight different parts of the planet receive. Serbian mathematician Milutin Milankovic calculated that these orbital variations occur in predictable cycles spanning tens of thousands of years, and for a long time, this theory seemed to explain everything. But recent research published in 2024 is challenging this long-held theory. Scientists examining geological records are finding patterns that don't quite match the Milankovic predictions. Some researchers are now proposing that ice ages might be caused by more complex interactions between orbital variations, ocean currents, atmospheric composition, and even feedback loops we haven't fully identified yet. Professor George Denton from the University of Maine, a leading Ice Age researcher, notes that most scientists who reference Milankovic's work haven't even read his original book. We may have been oversimplifying a far more complex system. But regardless of what caused the ice ages, the important question is, what was it like to actually live during one? The peak of the last glacial period, called the last glacial maximum, occurred about 21,000 to 20,000 years ago. At this time, ice sheets reached their maximum extent and the planet was dramatically different from today. Sea levels were approximately 400 feet lower than present because so much water was locked up in ice sheets. This exposed vast areas of continental shelf that are now underwater. A land bridge called Beringia connected Asia to North America, allowing animals and humans to walk between continents. The English Channel didn't exist. You could walk from France to England. Indonesia was connected to the Asian mainland. Australia and New Guinea were joined. The geography of Earth was completely different. And the climate? Imagine a world where average global temperatures were about 4 to 7 degrees Celsius colder than today. That might not sound like much, but the effects were dramatic. Much of North America, down to what is now New York, was buried under ice. Northern Europe was covered in glaciers. Vast areas that are temperate forests today were frozen tundra. But here's what's fascinating. Other areas became more habitable. The Sahara Desert, which today is one of the driest places on Earth, received much more rainfall during certain periods of the Ice Age. It was covered in grasslands and lakes, teeming with wildlife and inhabited by human populations. We have cave paintings from the Sahara showing people swimming in rivers and hunting hippos and crocodiles in the middle of what is now a vast desert. And it was in this Ice Age world that humanity evolved and spread across the globe. Our species, Homo sapiens, first appeared in Africa roughly 250 to 350,000 years ago, well before the last glacial maximum. But it was during the Ice Age that humans really came into their own. According to recent research published in Discover magazine, humans survived the Ice Age through a combination of factors that set us apart from other hominin species. While Neanderthals, Denisovans, Homo erectus, and other human relatives went extinct, Homo sapiens persisted. Why? Dr. John Shea, a paleoanthropologist who studies Ice Age humans, explains, hominins share a set of ancestral survival skills. They spent their time in complex social communities. They communicated among themselves, imagined innovative solutions to their problems, and invented and implemented specialized tools. It's not that we had something these extinct hominins lacked. It's that we used those skills differently.
Nans had was superior communication and information sharing. While other hominins could communicate, our species developed more sophisticated language abilities. This allowed us to share knowledge about hunting techniques, dangerous animals, edible plants, water sources, and survival strategies across generations and between groups. And we needed every advantage we could get because Ice Age Earth was populated by some of the most incredible and terrifying creatures ever to exist. Let me paint you a picture of the megafauna, the giant animals that dominated Ice Age Earth. In North America, woolly mammoths roamed in massive herds. These weren't just big elephants with fur. They were perfectly adapted Ice Age machines. Standing up to 14 feet tall at the shoulder and weighing up to 12 tons, mammoths have thick layers of fat, dense wool undercoats, and long guard hairs that could grow over 3 feet long. Their curved tusks could reach 16 feet in length and weighed up to 200 pounds each. Recent research has found mammoth remains with preserved stomach contents, showing they ate vast quantities of grass, sedges, and other plants, up to 400 pounds per day. But mammoths had company. Mastodons, slightly smaller and preferring forested areas, browsed on trees and shrubs. Giant ground sloths, yes, giant ground sloths, could weigh up to 8,000 pounds and stand 12 feet tall on their hind legs. Unlike their modern tree-dwelling descendants, these monsters were terrestrial herbivores with massive claws. And then there were the predators. Saber-toothed cats, properly called Smilodon, had canine teeth that could grow up to 11 inches long. These weren't just for show. Biomechanical studies suggest they used these incredible teeth to deliver precise killing bites to the throats of large prey animals. Dire wolves, larger and more robust than modern gray wolves, hunted in packs. Short-faced bears, possibly the largest land predator mammals that ever lived, could stand 12 feet tall and weigh over 2,000 pounds. In Eurasia, woolly rhinoceroses with thick fur and massive horns grazed alongside mammoths. Cave bears hibernated in limestone caves across Europe. Irish elk, actually giant deer, had antlers spanning up to 12 feet across, the largest antlers of any deer species ever. Giant beavers the size of modern black bears built dams in North American rivers. In Australia, megafauna included Diprotodon, a wombat the size of a modern rhinoceros weighing up to 6,000 pounds. Giant kangaroos stood 10 feet tall. Massive flightless birds called Genyuronis roamed the outback. And the continent was home to Megalania, a monitor lizard that could grow up to 23 feet long and weigh 1,300 pounds, the largest terrestrial lizard ever. Research examining these Ice Age ecosystems suggests that megafaunal biomass, the total weight of all large animals, may have been 30 times greater than what exists in the same regions today. The Ice Age world was packed with massive creatures, far more than modern ecosystems support. And for millions of years, these animals thrived. Mammoths, for example, first appeared about 5 million years ago. They survived through dozens of climate cycles, adapting to advancing and retreating ice sheets, warming and cooling periods. They were survivors, perfectly adapted to their environment. But then, starting around 50,000 years ago and accelerating dramatically between 15,000 and 10,000 years ago, something catastrophic happened. The megafauna began to disappear. And this is where our story becomes truly shocking, controversial, and relevant to today. The extinction of the Ice Age megafauna remains one of the most debated topics in science. Researchers have been arguing about it for over 150 years, and new discoveries are constantly challenging old theories. There are four main hypotheses that scientists debate: the overkill hypothesis, the climate change hypothesis, the disease hypothesis, and what's called the combination hypothesis that suggests multiple factors working together. Let's start with the overkill hypothesis, first championed by geoscientist Dr. Paul Martin from the University of Arizona. The overkill theory is simple but disturbing. Humans hunted the megafauna to extinction. And when you look at the evidence, it's compelling and terrifying in its implications. Here's the pattern that researchers have documented. Wherever humans arrived on a continent or island for the first time, massive extinctions of large animals followed shortly after. The correlation is almost perfect, and it's repeated across the globe in ways that seem too consistent to be coincidence. In Australia, humans arrived approximately 46,000 years ago. Within a few thousand years, giant wombats, massive kangaroos, huge flightless birds, and other megafauna went extinct. In North America, humans crossed the Bering Land Bridge from Asia around 15,000 to 13,000 years ago. By 11,000 years ago, mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, horses, and camels were gone. In South America, human arrival 14,000 to 13,000 years ago was followed by massive extinctions 14,000 to 8,000 years ago. The pattern continues. When humans reached Madagascar around 2,000 years ago, elephant birds, giant lemurs, and other megafauna vanished within centuries. When Polynesians reached New Zealand about 700 years ago, massive flightless moa birds that had lived there for millions of years went extinct within 100 years. When humans reached the Caribbean islands, massive ground sloths that had survived there for thousands of years disappeared. One species held on in Cuba until just 3,500 years ago. The evidence goes beyond just correlation. Archaeologists have found direct evidence of humans hunting megafauna. A study published in Science Advances in 2024 found mammoth bones with spear points embedded in them. Cave paintings show humans hunting mammoths, giant bison, and other Ice Age animals. Archaeological sites contain the remains of butchered megafauna with cut marks from stone tools clearly visible on bones. And humans had devastating hunting technology. The Clovis people of North America developed large spear points that could be attached to wooden shafts and launched using an atlat, a throwing stick that acted like a lever to multiply throwing force. This technology allowed hunters to kill massive animals from a safe distance. Studies of Clovis sites show evidence of mass killings, multiple mammoths slaughtered at once. But here's what makes the overkill hypothesis so compelling and disturbing. Large animals reproduce slowly. An elephant, for example, has a gestation period of nearly 2 years and typically only produces one offspring at a time. Mammoths would have been similar. This means that even modest hunting pressure could drive populations into decline. Dr. Emily Lindsay, curator at the La Brea Tar Pits, explains, "You don't have to hunt down every living mammoth to cause an extinction. You just have to hunt slightly more than are being born each year. With slow reproduction rates, large animals are incredibly vulnerable to overharvesting." And there's another factor, naivety. When humans first arrived in new lands, the animals there had never encountered human hunters before. They wouldn't have recognized humans as threats. They would have been easy prey, allowing hunters to walk right up to them. Modern examples support this. When European explorers first reached remote islands, they found that birds and other animals showed no fear of humans and could be easily captured by hand. Proponents of the overkill hypothesis point out that megafauna in Africa, where humans and large animals evolved together for millions of years, had much higher survival rates. African elephants, rhinoceroses, hippos, and other megafauna survived because they co-evolved with human hunters and learned to fear and avoid us. But animals in America, Australia, and other regions had no such evolutionary history with humans and were defenseless. Computer models support this scenario. Researchers have created simulations showing that even with conservative estimates of human hunting rates, megafaunal populations could be driven to extinction within just a few centuries or millennia, exactly matching the timelines we see in the fossil record. A 2023 paper concluded there was no support for an extinction driven primarily or even secondarily by climate, and placed the blame squarely on human hunting. But not all scientists agree, and this is where the story gets more complex and even more disturbing. The climate change hypothesis proposes that rapid warming at the end of the Ice Age transformed ecosystems in ways that large animals couldn't adapt to quickly enough. Here's what we know happened. Starting around 20,000 years ago, Earth began warming rapidly. Ice sheets started melting. Sea levels began rising. And crucially, vegetation patterns changed dramatically. During the Ice Age, much of the northern hemisphere was covered by what scientists call mammoth steppe.
Herds were replaced by less nutritious vegetation and, in many areas, by forest or bog. Research published in 2024 examining the last ice area in the Arctic found evidence of these dramatic ecosystem changes. As temperatures rose, peatlands spread rapidly, transforming formerly productive grazing lands into waterlogged bogs unsuitable for large grazing animals. For mammoths and other grazers adapted to open grasslands, this was catastrophic. Without enough food, populations crashed. And when the herbivores disappeared, the predators that depended on them, saber-toothed cats, dire wolves, giant bears, followed them into extinction. Dr. Matthew Stewart, a zoo archaeologist at Griffith University who has studied Ice Age extinctions, argues, dozens of studies, including papers I've co-authored, have pointed to terminal cooling and habitat change as the main driver of the megafauna extinctions. There's also evidence of something called the Younger Dryas, a period of abrupt cooling from 12,900 to 11,700 years ago that interrupted the general warming trend. Some researchers believe this sudden return to near-glacial conditions delivered a final blow to megafaunal populations that were already stressed by earlier climate changes. And climate change advocates point to something important. These animals had survived previous climate changes. Mammoths had lived through at least 12 previous glacial-interglacial cycles. Why would this transition be any different? But this leads to the most likely explanation, the combination hypothesis, which suggests that the truth is more complex and more frightening than either climate or hunting alone. What if both factors work together? What if climate change stressed megafaunal populations, reducing their numbers and making them more vulnerable, and then human hunting finished them off? A 2023 paper by Dr. Emily Lindsay and colleagues examined megafaunal extinctions in California and found evidence of human-ignited fires that transformed vegetation patterns. These fires, combined with climate change, hunting pressure, and drought, created what researchers call a perfect storm of stressors that large animals couldn't withstand. The combination hypothesis explains puzzling aspects of the extinctions. For example, extinctions happened at different times on different continents, suggesting local factors like human arrival mattered more than global climate. But the extinctions consistently targeted large animals while smaller animals survived, suggesting that factors like slow reproduction rates and naivety to human hunters played crucial roles.
Recent research published in Nature Communications in 2025, examining Antarctic ocean conditions during the last deglaciation, found that ocean circulation changes happened simultaneously in both hemispheres, affecting global climate in complex ways that scientists are still working to understand. These findings suggest the climate system during Ice Age transitions was far more complicated and unstable than previously thought. And here's what's truly terrifying. Whether it was climate change, hunting, or both, the result was the same. Within just a few thousand years, an eye blank in evolutionary time, Earth's megafauna was gone. Creatures that had thrived for millions of years vanished. Ecosystems that had existed since the Pleistocene were completely transformed. But the extinction of the megafauna didn't just change animal populations. It changed everything, including human civilization itself. And this brings us to perhaps the most shocking revelation about the Ice Age extinctions. They might have forced humans to invent civilization. Think about this. Modern Homo sapiens evolved roughly 250,000 to 350,000 years ago. But for 95% of our species' history, for roughly 240,000 years, we lived as hunter-gatherers in small, nomadic bands. We didn't farm, we didn't build permanent settlements, we didn't develop writing, complex governments, or cities. Then, quite suddenly, starting around 10,000 years ago, everything changed. Humans began cultivating plants, we domesticated animals, we built permanent villages that grew into towns and then cities. We developed complex social hierarchies, organized religions, writing systems, and all the trappings of what we call civilization. Why? What changed? Research examining this question has revealed something disturbing. The agricultural revolution, the transition from hunting and gathering to farming, happened almost exactly when the megafauna disappeared. The correlation is too strong to be coincidence. Scientists like Dr. Christopher Stringer have proposed a controversial but compelling hypothesis. Civilization wasn't born from human innovation or a drive to progress. It was born from disaster. The extinction of the megafauna created a crisis that forced humans to change how we lived. Here's how this might have worked. For hundreds of thousands of years, humans relied heavily on hunting large animals. Killing a single mammoth could provide thousands of pounds of meat, enough to feed a group for weeks. The archaeological record shows that Ice Age humans were skilled big-game hunters who regularly took down massive prey. This was an efficient lifestyle. Hunting large animals provided far more calories per unit of effort than hunting small game or gathering plants. It allowed humans to maintain mobile, flexible lifestyles without being tied to specific locations. But when the megafauna disappeared, this strategy became impossible. Sure, people could hunt smaller game like rabbits and deer, but these animals provided far fewer calories and were harder to catch in sufficient numbers. The old way of life was no longer viable. Studies examining human remains from the transition period show evidence of nutritional stress. People were struggling. The easy abundance of the Ice Age hunting lifestyle was gone. So humans had to adapt. We focused more heavily on gathering and eventually cultivating plants. We developed agriculture not because we wanted to, but because we had to survive. Research published in The Conversation examining this transition notes, perhaps civilization wasn't born out of a drive to progress, but disaster, as ecological catastrophe forced people to abandon their traditional lifestyles. And agriculture, despite what we might think, was actually a step backward in many ways. Studies of skeletal remains show that early farmers were actually less healthy than hunter-gatherers. They were shorter, had more diseases, worse dental health, and more evidence of malnutrition. They worked harder and lived shorter lives. But farming had one crucial advantage. It could support larger, denser populations. Hunter-gatherers need large territories to find enough food, but farmers could produce enough food in a small area to support many people. This allowed for the development of permanent settlements, which eventually grew into towns and cities. And once agriculture got started, there was no going back. You can't sustain large, dense populations through hunting and gathering. Once human populations grew beyond a certain size, we were locked into the agricultural lifestyle. So, in a very real sense, modern civilization, cities, governments, technology, everything exists because humans hunted Ice Age megafauna to extinction and then had to invent new ways to survive. We caused the first great extinction crisis, and it transformed human society forever. But here's what's truly terrifying. Whether it was climate change, hunting, or both, the result was the same. Within just a few thousand years, an eye blank in evolutionary time, Earth's megafauna was gone. Creatures that had thrived for millions of years vanished. Ecosystems that had existed since the Pleistocene were completely transformed. But the extinction of the megafauna didn't just change animal populations, it changed everything, including human civilization itself. And this brings us to perhaps the most shocking revelation about the Ice Age extinctions. They might have forced humans to invent civilization. Think about this. Modern Homo sapiens evolved roughly 250,000 to 350,000 years ago. But for 95% of our species' history, for roughly 240,000 years, we lived as hunter-gatherers in small, nomadic bands. We didn't farm, we didn't build permanent settlements, we didn't develop riding, complex governments, or cities. Then, quite suddenly, starting around 10,000 years ago, everything changed. Humans began cultivating plants, we domesticated animals, we built permanent villages that grew into towns and then cities. We developed complex social hierarchies, organized religions, writing systems, and all the trappings of what we call civilization. Why? What changed? Research examining this question has revealed something disturbing. The agricultural revolution, the transition from hunting and gathering to farming, happened almost exactly when the megafauna disappeared. The correlation is too strong to be coincidence. Scientists like Dr. Christopher Stringer have proposed a controversial but compelling hypothesis. Civilization wasn't born from human innovation or a drive to progress. It was born from disaster. The extinction of the megafauna created a crisis that forced humans to change how we lived. Here's how this might have worked. For hundreds of thousands of years, humans relied heavily on hunting large animals. Killing a single mammoth could provide thousands of pounds of meat, enough to feed a group for weeks. The archaeological
Extinctions don't always happen gradually. The megafaunal extinctions were geologically rapid, happening over just a few thousand years. When conditions change faster than species can adapt, even animals that survived for millions of years can vanish remarkably quickly. Second, large animals are particularly vulnerable to extinction. Their slow reproduction rates mean they can't recover quickly from population declines. This is true today as it was 12,000 years ago. Third, climate change and human activity can interact in devastating ways. Climate change alone might not have doomed the megafauna. Human hunting alone might not have either. But together, they created conditions that even highly successful, well-adapted species couldn't survive. Fourth, extinctions have cascading effects on entire ecosystems. When the megafauna disappeared, the ecosystems they inhabited were fundamentally transformed. Grasslands that mammoths maintained through their grazing turned to forests or peat bogs. Predator populations crashed when their prey disappeared. The loss of large animals changed nutrient cycling, seed dispersal, vegetation patterns, everything. And fifth, extinctions can force human societies to change in fundamental ways. The loss of the megafauna forced humanity to invent agriculture, which led to civilization, which ultimately brought us to where we are today. Understanding the Ice Age extinctions also gives us insights into how species survive dramatic changes. Some animals made it through the extinctions. Bison, caribou, muskox, elk, moose, these species survived the transition from Ice Age to modern conditions. Why did they make it when mammoths, horses, and giant ground sloths didn't?
Research examining survivors versus extinct species has identified some patterns. Animals that could eat a variety of foods were more likely to survive than specialists. Animals that could thrive in different habitats did better than those dependent on specific conditions. Animals that reproduced relatively quickly had better chances than slow breeders. And crucially, animals that humans found less useful as prey were more likely to survive. Musk ox and caribou, while hunted, were apparently not targeted as intensively as mammoths and horses, possibly giving them breathing room to recover between hunting events. There's also evidence that some megafaunal species survived far longer in isolated refuges than previously thought. Woolly mammoths, believed extinct by 10,000 years ago, actually survived on Wrangel Island near Siberia until about 4,000 years ago, long after the pyramids were built. They persisted in this isolated refuge for thousands of years while going extinct everywhere else. Irish elk, thought to have disappeared at the end of the Pleistocene, actually survived in the Ural Mountains until at least 7,600 years ago. These Lazarus species, animals thought extinct but later discovered to have survived, remind us that extinction is complex and that populations can sometimes persist in unexpected places. But what about humans? How did our ancestors cope with the dramatic changes at the end of the Ice Age? Humans survived the Ice Age transition remarkably well, but we had to adapt. As the megafauna disappeared and forced us toward agriculture, human societies underwent revolutionary changes. Population densities increased dramatically. Hunter-gatherer bands of 20 to 50 people gave way to farming villages of hundreds or thousands. These dense populations required new forms of social organization, leadership structures, laws, ways of resolving conflicts between people who weren't all related by blood. Technology advanced rapidly. The pressure to produce enough food led to innovations in tools, techniques, and eventually metallurgy. Writing systems developed to keep track of agricultural surpluses and trade. But perhaps most importantly, the human relationship with nature changed fundamentally. Hunter-gatherers saw themselves as part of nature, taking what they needed but generally living in balance with their environment. But farmers had to control and manipulate nature. They cleared forests, diverted water, killed predators, and selected which plants and animals would survive and reproduce. This shift in perspective, from being part of nature to being separate from and attempting to control nature, is arguably the most significant change in human history. And it came about because the Ice Age megafauna disappeared. Now, let's talk about some of the most fascinating specific cases of Ice Age survival and extinction, because the details reveal just how complex and surprising this story really is. Take horses, for example. Wild horses thrived in North America throughout the Ice Age. They were one of the dominant species on the Mammoth steppe. Archaeological evidence shows that Ice Age humans in North America hunted and ate horses regularly. Then, around 11,000 years ago, horses in North and South America went extinct, completely disappeared. For thousands of years, there were no horses anywhere in the Americas. But horses survived in Eurasia. And when Spanish conquistadors brought horses back to the Americas in the 1500s, the animals thrived in their former homeland. Wild horse populations exploded across the American West. This raises fascinating questions. Why did horses survive in Eurasia but not America? The climate changes affected both continents. Humans hunted horses in both places, yet the outcome was different. One hypothesis is that hunting pressure was simply more intense in the Americas, because human populations were growing rapidly after their initial arrival. While in Eurasia, humans and horses had co-evolved for hundreds of thousands of years, perhaps reaching some kind of equilibrium. Or consider the case of bison. Ice Age North America was home to several species of giant bison, some weighing over 3,000 pounds, much larger than modern bison. These giant forms went extinct, but a smaller species of bison survived and thrived, eventually becoming the millions of animals that covered the Great Plains when European explorers arrived. Why did small bison survive while giant bison didn't? Perhaps the smaller animals could reproduce faster, allowing populations to recover from hunting and climate stress. Or perhaps humans preferentially targeted the larger, more impressive animals, giving smaller bison a survival advantage. The story gets even more interesting when we look at islands. Throughout the Ice Age, some megafaunal species survived on islands long after they went extinct on continents. Mammoths persisted on Wrangel Island, a remote Arctic island, until approximately 4,000 years ago. That means mammoths were still alive when the Egyptians were building pyramids, when Stonehenge was already ancient, when Bronze Age civilizations were flourishing. These dwarf mammoths, they evolved to be smaller on the island through a process called insular dwarfism, survived in isolation for thousands of years. Eventually they succumbed, possibly to climate change, genetic problems from inbreeding in their small population, or human hunting when people finally reached the island. Irish elk, thought to have disappeared at the end of the Pleistocene, actually survived in the Ural Mountains until at least 7,600 years ago. These Lazarus species, animals thought extinct but later discovered to have survived, remind us that extinction is complex and that populations can sometimes persist in unexpected places. But what about humans? How did our ancestors cope with the dramatic changes at the end of the Ice Age? Humans survived the Ice Age transition remarkably well, but we had to adapt. As the megafauna disappeared and forced us toward agriculture, human societies underwent revolutionary changes. Population densities increased dramatically. Hunter-gatherer bands of 20 to 50 people gave way to farming villages of hundreds or thousands. These dense populations required new forms of social organization, leadership structures, laws, ways of resolving conflicts between people who weren't all related by blood. Technology advanced rapidly. The pressure to produce enough food led to innovations in tools, techniques, and eventually metallurgy. Writing systems developed to keep track of agricultural surpluses and trade. But perhaps most importantly, the human relationship with nature changed fundamentally. Hunter-gatherers saw themselves as part of nature, taking what they needed but generally living in balance with their environment. But farmers had to control and manipulate nature. They cleared forests, diverted water, killed predators, and selected which plants and animals would survive and reproduce. This shift in perspective, from being part of nature to being separate from and attempting to control nature, is arguably the most significant change in human history. And it came about because the Ice Age megafauna disappeared. Now, let's talk about some of the most fascinating specific cases of Ice Age survival and extinction, because the details reveal just how complex and surprising this story really is. Take horses, for example. Wild horses thrived in North America. They were one of the dominant species on the Mammoth steppe. Archaeological evidence shows that Ice Age humans in North America hunted and ate horses regularly. Then, around 11,000 years ago, horses in North and South America went extinct, completely disappeared. For thousands of years, there were no horses anywhere in the Americas. But horses survived in Eurasia. And when Spanish conquistadors brought horses back to the Americas in the 1500s, the animals thrived in their former homeland.
Fascinating is research examining ancient DNA recovered from permafrost and ice cores. Scientists can now extract and sequence DNA from extinct animals, giving us unprecedented insights into Ice Age life. In 2021, researchers successfully sequenced the complete genome of a woolly mammoth from a specimen over 1 million years old, the oldest DNA ever recovered. This genetic information tells us about mammoth evolution, population dynamics, and relationships between different mammoth populations. Even more remarkably, scientists are using this genetic information to explore the possibility of de-extinction, bringing extinct species back to life through genetic engineering. Teams are working on projects to resurrect the woolly mammoth by inserting mammoth genes into elephant embryos, creating what they call a mammophont,
an elephant modified with mammoth traits like thick fur and cold tolerance. Dr. George Church from Harvard University leads one such effort. He argues that resurrecting mammoths could help restore Arctic ecosystems and even slow permafrost melting by recreating the grasslands that mammoths maintained through their grazing and trampling. But critics worry about the ethics and practicality of de-extinction. Is it right to bring back extinct species? Would they have anywhere to live? Could they survive in modern ecosystems? And most importantly, should we focus on bringing back extinct species when we're failing to save endangered species that still exist? These questions don't have easy answers, but they illustrate how Ice Age extinctions remain relevant today. Recent research is also uncovering surprising details about how humans and megafauna interacted. A 2024 study examining archaeological sites found evidence that Ice Age humans didn't just hunt megafauna. They had complex relationships with these animals. Some sites show evidence of scavenging, humans finding already dead mammoth and butchering them for meat and materials. Other sites suggest that humans may have driven animals into traps or over cliffs, killing many individuals at once in what researchers call mass kill events. And fascinatingly, there's evidence that humans used virtually every part of killed animals. Mammoth bones were used to build shelters in areas where wood was scarce. Mammoth ivory was carved into tools, weapons, and art. Hides provided clothing and shelter materials. Nothing was wasted. This suggests that Ice Age humans had deep knowledge of megafauna biology and behavior. They weren't just randomly killing animals. They were expert hunters who understood their prey intimately. There's even evidence that humans may have had semi-domestic relationships with some animals. While full domestication of animals like dogs, sheep, and cattle came after the Ice Age, some researchers have suggested that late Ice Age humans may have been managing or even semi-domesticating certain megafaunal species, particularly horses and reindeer. If this is true, it adds another tragic dimension to the extinctions. These weren't just wild animals disappearing. They were species that humans had relationships with, depended on, and possibly even cared for in some way. Now, let's talk about one of the most controversial and sensational theories about Ice Age extinctions, the impact hypothesis. Some researchers have proposed that a comet or asteroid impact around 12,900 years ago triggered the Younger Dryas cooling event and contributed to megafaunal extinctions. This theory, often called the Younger Dryas impact hypothesis, suggests that an extraterrestrial object exploded over North America, causing widespread fires, climate disruption, and ecosystem collapse. Proponents point to evidence like unusual concentrations of platinum and other elements at geological layers corresponding to the Younger Dryas boundary, along with what they interpret as impact markers like shocked quartz and carbon spherules. The theory is appealing because it would explain the sudden onset of the Younger Dryas cooling and provide a dramatic single cause for extinctions. Some versions of the hypothesis even suggest that the impact destroyed a pre-existing advanced human civilization, inspiring myths about catastrophic floods and fallen civilizations. But most scientists are skeptical. Detailed studies of the supposed impact markers have found natural explanations for many of them. The concentrations of unusual elements can be explained by volcanic activity or other non-impact processes. And the timing doesn't quite work. Megafaunal extinctions in different regions happened at different times, not all simultaneously as would be expected from a single catastrophic impact. A 2024 review of the evidence concluded that while an impact can't be completely ruled out, there's no compelling evidence for one. And the extinction pattern is better explained by climate change and human hunting. Still, the debate continues, and some researchers are still looking for definitive proof one way or the other. It's a reminder that despite decades of study, the Ice Age extinctions still hold mysteries. But here's what we do know with certainty. The world changed dramatically at the end of the Ice Age, And those changes shaped everything that came after. Let me paint you a picture of what this transition looked like in different parts of the world, because the details are fascinating and help us understand how profoundly the planet was transformed. In North America, the melting of the massive Laurentide ice sheet created dramatic changes. As the ice melted, it formed huge glacial lakes, some larger than the Great Lakes we know today. Periodically, ice dams holding back these lakes would fail, releasing catastrophic floods that carved enormous channels across the landscape. The channeled scablands in Washington state show evidence of some of the largest floods in Earth's history. Floods so massive they carved canyons hundreds of feet deep in solid rock within days. These were released by the catastrophic draining of Glacial Lake Missoula, which held more water than Lakes Erie and Ontario. Imagine witnessing such a flood. A wall of water hundreds of feet high, moving faster than you could run, carrying icebergs the size of buildings, boulders the size of houses, scouring the landscape clean of everything in its path. The thunder of the water would have been audible from miles away. The ground would have shaken, and in just a few days, the entire landscape would have been transformed. These floods happened multiple times as the ice sheet advanced and retreated during the final stages of the Ice Age. Each time, ecosystems were destroyed and rebuilt. Animals and plants that had adapted to conditions created by the previous flood were wiped out by the next one. And of course, humans living in these areas had to adapt to or flee from these dramatic changes. Archaeological evidence suggests that human populations in affected areas were highly mobile during this period, constantly moving to track resources and avoid environmental catastrophes. In Europe, the melting of ice sheets opened up vast areas that had been buried under ice for thousands of years. As the ice retreated northward, plants, animals, and humans followed, colonizing the newly available land. But this wasn't a smooth process. The climate didn't just gradually warm, it fluctuated wildly. The Younger Dryas event from 12,900 to 11,000 years ago brought a sudden return to near glacial conditions. Temperatures dropped dramatically, ice began to advance again, and species that had been expanding northward suddenly found their habitats shrinking. For megafauna already stressed by previous climate changes and human hunting, this may have been the final straw. Populations that were hanging on in scattered refuges were pushed over the edge into extinction. In the Middle East, the end of the Ice Age created the conditions that allowed agriculture to develop. The region that would become known as the Fertile Crescent had the right combination of wild grain plants and potential domesticates that made early farming possible. Around 11,500 years ago, people in this region began cultivating wild wheat and barley. By 10,000 years ago, they were domesticating animals like sheep and goats. Within a few thousand years, farming communities had spread across the Middle East, into Europe, North Africa, and Asia. This agricultural revolution, born from the crisis of megafaunal extinction and climate change, would ultimately transform the entire world. But it came at a cost. Studies of skeletal remains from this transition period show that early farmers were less healthy than their hunter-gatherer ancestors. They were shorter, they had more dental problems, more diseases, and more evidence of nutritional deficiencies. The agricultural lifestyle was harder work and provided less diverse nutrition than hunting and gathering. But agriculture had one crucial advantage: it could support more people. A farmer could produce more calories per unit of land than a hunter-gatherer could obtain from the same area. This meant that farming populations could grow larger and denser than hunter-gatherer populations. And once populations grew past a certain size, there was no going back. You can't support thousands of people in a small area through hunting and gathering. Agriculture became self-reinforcing. More people
acquired more farming, which allowed even more people, which required even more farming. Within a few thousand years, agricultural societies had developed all the features we associate with civilization: permanent settlements, social hierarchies, specialized occupations, organized religion, writing systems, and eventually cities and states.
And all of this traces back to the crisis created by Ice Age extinctions. If mammoths and other megafauna had survived, would humans have invented agriculture? Would we have developed cities and civilizations? Or would we still be living as mobile hunter-gatherers? We can't know for certain, but the coincidence of timing, megafaunal extinction followed immediately by agricultural development, suggests a causal relationship. Now let's explore what Ice Age extinctions and transformations looked like in other parts of the world, because each region has its own unique story. In Australia, the story is particularly dramatic and tragic. Australia's megafauna was even more bizarre than North America's. Giant marsupials like Dipdodon. Imagine a wombat the size of a car. Huge kangaroos that stood 10 feet tall and couldn't hop because they were too massive. Marsupial lions with bolt-cutter jaws that could crush bones. And Megalaia, a monitor lizard potentially up to 23 feet long and 1,300 pounds, a real-life dragon. Research suggests humans arrived in Australia around 46,000 to 50,000 years ago. Within about 10,000 years, possibly much less, all of Australia's megafauna was extinct. Every single species of large animal disappeared. The evidence for human involvement is particularly strong in Australia. The extinctions happened well before the major climate changes at the end of the Ice Age, suggesting climate wasn't the primary driver. And the timing perfectly matches human arrival. Some researchers have suggested that humans transformed the Australian landscape through fire, burning vegetation in ways that altered habitats and made them unsuitable for megafauna. Aboriginal Australians used fire extensively to manage landscapes, clearing undergrowth, promoting new growth to attract game, and controlling vegetation patterns. But while this fire management created sustainable ecosystems over the long term, the initial transition from megafauna-dominated ecosystems to human-managed landscapes may have been catastrophic for species that couldn't adapt quickly enough. In South America, the extinction pattern was similarly dramatic. Giant ground sloths, massive armadillos, saber-toothed predators, native horses and camels, enormous rodents, all disappeared within a few thousand years of human arrival, around 14,000 years ago. But here's something fascinating. Some South American megafauna survived longer than their North American counterparts. Giant ground sloths persisted in parts of South America until possibly 8,000 years ago, thousands of years after North American megafauna disappeared. This suggests that local conditions mattered. Perhaps South American landscapes provided more refuges where animals could avoid human hunters. Perhaps human populations grew more slowly in South America, giving animals more time to adapt. Or perhaps South American humans developed different hunting strategies that were less devastating to megafauna populations. Madagascar offers perhaps the most clear-cut case of human-caused extinction. This large island off the coast of Africa was home to incredible creatures. Elephant birds standing 10 feet tall and weighing up to 1,000 pounds, with eggs that could hold 2 gallons of liquid. Giant lemurs the size of gorillas, massive tortoises, a diverse array of large animals found nowhere else on Earth. Humans arrived in Madagascar around 2,000 years ago, very recently in geological terms. Within centuries, elephant birds, giant lemurs, and other megafauna were gone. The correlation between human arrival and extinction is undeniable. And because this happened so recently, we have more detailed evidence, including the remains of butchered megafauna and even possible human hunting sites. Madagascar demonstrates what happens when humans encounter naive megafauna with no evolutionary experience of human hunters. The animals had no fear of people, no defensive behaviors, no adaptations for avoiding human hunting. They were easy prey, and they disappeared with shocking speed. And New Zealand provides an even more recent example. When Polynesian settlers reached New Zealand about 700 years ago, so recently that we have historical records from just a few centuries later, They found enormous flightless birds called moa. There were 9 species of moa, ranging from turkey-sized to massive birds standing 12 feet tall and weighing over 500 pounds. These birds had no natural predators before humans arrived. They had never needed to develop fear responses or defensive behaviors. Within approximately 100 years of human arrival, all 9 moa species were extinct. Archaeological sites contain massive dumps of moa bones, evidence of intensive hunting. The extinction was so rapid and so complete that by the time European explorers reached New Zealand in the 1700s, moa were already just a memory in Maori oral traditions. These island examples are particularly important because they eliminate many confounding factors. Climate change can't explain extinctions that happened at different times on different islands. The extinctions consistently follow human arrival within centuries or at most a few millennia. The pattern is clear and undeniable. But understanding past extinctions isn't just an academic exercise. It has crucial implications for conservation today and for understanding our own future. Current extinction rates are alarmingly high, possibly the highest since the dinosaurs disappeared 66 million years ago. And just like during the Ice Age extinctions, large animals are particularly vulnerable. African elephants, whose ancestors survived the Ice Age extinctions in Africa, are now threatened by ivory poaching. Rhinoceros, hunted for their horns, are critically endangered. Tigers, once ranging across Asia, survive in tiny fragmented populations. Whales, slaughtered by industrial whaling, are only slowly recovering. Gorillas, our closest relatives, face habitat destruction and hunting pressure. If current trends continue, these animals could be extinct within decades. And unlike the Ice Age extinctions, we can't claim ignorance. We know exactly what's happening. We understand the causes. We have the knowledge and potentially the resources to prevent these extinctions. But will we? That's the question that will define our generation. The Ice Age extinctions teach us that extinction happens faster than we expect, that large animals are particularly vulnerable, that climate change and human activity can combine in devastating ways, and that extinctions transform entire ecosystems with unpredictable consequences. They also teach us that humans are capable of causing extinctions on a massive scale, perhaps unintentionally, perhaps through short-term thinking that prioritize immediate needs over long-term sustainability, but devastating nonetheless. But the Ice Age also shows us something else, that humans are incredibly adaptable. Our ancestors survived the ice sheets, megafaunal extinctions, dramatic climate changes, and the transition from hunting to farming, all with Stone Age technology. Then surely we have the capability to address our current environmental challenges. The question is whether we have the will to do so before it's too late. Now let me tell you about some of the most cutting-edge research that's changing our understanding of Ice Age extinctions right now, in 2024 and 2025. Scientists are using new techniques to extract and analyze ancient DNA from soil samples, a method called environmental DNA, or eDNA. By analyzing dirt from Ice Age layers, researchers can identify what species were present even without finding any bones or fossils. This technique has revealed that some animals persisted in areas where no fossils had been found, showing that extinctions weren't always complete and immediate. Some species hung on in scattered refuges before finally disappearing. Researchers are also using isotopic analysis of ancient bones to understand what Ice Age animals ate and how their diets changed as the climate shifted. This provides insights into how ecosystems were transformed. For example, studies of mammoth tusks have revealed that these animals' diets changed significantly in the final millennia before extinction. As grasslands transformed to different vegetation types, mammoths struggled to find adequate nutrition. Their tusks show signs of nutritional stress, evidence that these once thriving animals were struggling to survive in changing conditions. Advanced climate modeling is allowing scientists to simulate ice age conditions with unprecedented accuracy. By combining geological data with sophisticated computer models, researchers can reconstruct temperature, precipitation, vegetation patterns, and even seasonal variations from thousands of years ago. These models are revealing that Ice Age climate was far more variable and unstable than previously thought.
Rather than smooth transitions between cold and warm periods, the climate experienced rapid swings, abrupt changes, and periods of extreme variability. This variability may have been more devastating to megafauna than the overall trend toward warming. Animals can potentially adapt to gradual change, but rapid, unpredictable swings are much harder to cope with. Researchers are also studying modern analogs to Ice Age extinctions. For example, scientists studying elephant populations in Africa are finding that overhunting and habitat fragmentation create similar pressures to those that Ice Age megafauna faced. By understanding how modern elephants respond to these pressures, we can make inferences about how mammoths and other extinct species might have responded to Ice Age stresses. And fascinatingly, some researchers are using machine learning and artificial intelligence to analyze patterns in fossil records and archaeological data. These AI systems can identify patterns that human researchers might miss, potentially revealing new insights into extinction mechanisms. One recent study used machine learning to analyze thousands of megafaunal fossil sites and archaeological locations. The AI identified spatial and temporal patterns, suggesting that human hunting pressure was more intense in areas with certain geographical features, potentially driving animals toward less optimal habitats where they were more vulnerable to climate stress. Now, let's talk about what all of this means for you personally living in the 21st century. You're living through a pivotal moment in Earth's history, a period of rapid environmental change that future humans will look back on the way we look back at the Ice Age extinctions. Climate is changing faster than at any time in human history. Species are going extinct at alarming rates, ecosystems are being transformed, and human activity is the primary driver of all these changes. The Ice Age extinctions took thousands of years to unfold. Modern extinctions are happening within decades or even years. The passenger pigeon went from billions of individuals to extinction in less than a century. The Baiji dolphin survived for millions of years before disappearing in 2006. The northern white rhino is functionally extinct with only 2 females remaining. These aren't just numbers and statistics. Each extinction represents millions of years of evolution erased, unique species with their own behaviors and ecological roles lost forever, and ecosystems degraded in ways we're only beginning to understand. And just like our Ice Age ancestors, we face a choice: adapt our behavior or face the consequences. The good news is that we have advantages our ancestors lacked. We understand the science of extinction and conservation. We have global communication that allows us to coordinate efforts across nations and continents. We have technology that could help us solve these problems if we choose to deploy it. Conservation efforts have saved species from extinction. The California condor, down to just 27 individuals in 1987, now numbers over 500 thanks to intensive conservation. The black-footed ferret, thought extinct in the wild, has been successfully reintroduced. Humpback whales, hunted nearly to extinction, have recovered dramatically after whaling bans. These success stories show that extinction isn't inevitable. When humans dedicate resources and effort to conservation, we can save species and restore ecosystems. But conservation isn't enough on its own. We need to address the underlying drivers of extinction: habitat destruction, overharvesting, pollution, invasive species, and climate change. This requires changes at every level: individual choices about consumption and lifestyle, corporate responsibility for environmental impacts, and government policies that prioritize sustainability over short-term economic gains. The Ice Age extinctions remind us that humans are capable of transforming the entire planet, for better or worse.
Our ancestors, with Stone Age technology and small populations, still managed to drive massive animals to extinction and reshape ecosystems worldwide. Today, with modern technology and billions of people, our capacity for environmental impact is vastly greater. We can cause extinction and environmental destruction on a scale our ancestors couldn't have imagined. But we also have the capacity to prevent extinctions, restore ecosystems, and create a sustainable relationship with the natural world. The question is whether we'll choose to do so. Now, let me leave you with some final thoughts that connect everything we've discussed. The Ice Age wasn't just some random period of Earth's history. It was the crucible in which modern humanity was forged. The challenges our ancestors faced, surviving in harsh climates, adapting to rapid environmental changes, coping with the extinction of the megafauna they depended on, shaped human societies in fundamental ways. We developed agriculture because we had to. We created civilization because we needed new ways to organize large populations. We spread across the entire planet because we were adaptable enough to survive anywhere. But the same qualities that allowed us to survive and thrive during the Ice Age, our ability to modify our environment, our efficiency as hunters, our capacity to transform ecosystems, are now threatening the natural world and potentially our own long-term survival. The shocking truth about the Ice Age is that it never really ended. We're still living in an Ice Age, just in a warm period called an interglacial. Based on past patterns, Earth should eventually return to glacial conditions unless human-caused climate change prevents it. We're living in a moment of transition between the Ice Age world our ancestors survived and whatever comes next. The choices we make now will determine whether that future is sustainable or catastrophic. The megafauna that dominated Ice Age Earth are gone, casualties of climate change, human hunting, or both. Their extinction forced humans to change, ultimately leading to agriculture, civilization, and the modern world. Today, we face our own crisis. Climate changing faster than ever, species disappearing at alarming rates, ecosystems under pressure worldwide. And just like our Ice Age ancestors, we must adapt or face disaster. But we have advantages they lacked. We understand what's happening. We know what needs to change. We have the technology and knowledge to address these challenges if we choose to act. The Ice Age extinctions show us that even massive, well-adapted species that survived for millions of years can disappear when conditions change faster than they can adapt. But they also show us that humans are incredibly resilient and capable of surviving and adapting to dramatic changes. The question isn't whether humans will survive our current environmental crisis. We're too adaptable, too clever, too widespread to go extinct easily. The question is, what kind of world we'll survive in? Will it be a world with elephants and rhinos and tigers? Or a world where we've driven most large animals to extinction like our ancestors did to mammoths and giant ground sloths? Will it be a world with stable climates and productive ecosystems, or a world of extreme weather and environmental catastrophes? These are the questions your generation will answer. The Ice Age ended 11,700 years ago, but its lessons are more relevant than ever. Our ancestors survived the Ice Age through adaptability, cooperation, and innovation. These same qualities could allow us to address modern environmental challenges. But we need to act soon. Species don't come back once they're extinct. Ecosystems take centuries or millennia to recover from damage. The longer we wait, the harder the problems become to solve. The Ice Age teaches us that Earth's climate and ecosystems can change dramatically and rapidly. It shows us that extinction happens faster than we expect. It demonstrates that humans have been transforming the planet for thousands of years. But it also shows us that humans can survive and adapt to incredible changes, that we're capable of fundamental changes in how we live, that crises can lead to innovations that transform society. The shocking truth about the Ice Age isn't just that it happened. It's that we're living through something similar right now. Another period of rapid environmental change, another wave of extinctions driven by human activity, Another moment when humanity must choose between continuing destructive patterns or adapting to create a sustainable future. Our Ice Age ancestors didn't have the luxury of understanding what was happening or choosing their path. They simply struggled to survive as the world changed around them. We're luckier. We understand the science. We can see what's coming. We can choose how to respond. The Ice Age extinctions forced humanity to invent civilization. What will our current crisis force us to invent? Perhaps new technologies for clean energy and sustainable living. Perhaps new ways of organizing society that prioritize long-term sustainability over short-term profit. Perhaps a new relationship with nature that sees us as part of ecosystems rather than separate from them. Or perhaps, like our Ice Age ancestors, we'll simply struggle through, adapting as best we can, transformed by the crisis.
In ways we can't predict. Either way, the story of the Ice Age and its extinctions remains one of the most important stories we can tell. It's a story about survival, adaptation, extinction, and transformation. It's a story about how environmental changes can reshape entire ecosystems and societies. And most importantly, it's a story that isn't over. Because we're still living it, still making choices that will determine how it ends. The mammoths are gone. The giant ground sloths are extinct. The saber-toothed cats will never roar again. But their story continues through us, in the civilizations we built on the foundations laid by their extinction, in the lessons we learn from their disappearance, and in the choices we make about the fate of elephants, tigers, rhinos, and all the megafauna that remain. The shocking truth about the Ice Age is that it's not ancient history. It's our story, and we're still writing the ending. So the next time you see a woolly mammoth in a museum or a documentary, remember, those magnificent creatures helped create the world you live in through their disappearance. Their extinction crisis forced humanity to change in ways that led to everything modern civilization has achieved. And remember that we're facing our own extinction crisis now. What we create from this crisis, what innovations, what changes, what new ways of living will shape human civilization for thousands of years to come. Just as agriculture, born from Ice Age extinctions, shaped the last 10,000 years. The Ice Age ended 11,700 years ago, but its impact echoes through every city you see, every crop you eat, every aspect of modern life. And its lessons about extinction, adaptation, and survival are more relevant today than ever before. The shocking truth about the Ice Age is that we're still living in its shadow, and the choices we make now will determine whether future generations tell our story as a warning or as an inspiration. Choose wisely.